Good afternoon, everyone, and welcome to today's webinar. My name's Matthew McKnight. I'm a technical specialist at Autodesk, working out of our Melbourne office today, and it looks to be a reasonably nice day outside. Thanks for joining us. Today we're going to be talking about the Autodesk nesting utility and give you a little bit of an introduction into the nesting utility and some of the reasons why you might look at using it. Rather than delaying, I'm just going to get stuck right into it, and let's have a quick look at what we'll be covering today, some of the key topics. Firstly, I'll just talk briefly about some of the typical challenges of a traditional nesting process. We'll look at what is the Autodesk nesting utility. I'll highlight some of the key functionality. We will go through a quick workflow to understand what all that looks like. Towards the end, I'll do a quick nesting technology comparison, because nesting technology is not new at Autodesk. So I'll give you a little bit of a brief overview of some other nesting technology that's out there and how it might differ from the Autodesk nesting utility. And then towards the end, we'll go over some frequently asked questions. So just quickly covering some of the typical nesting challenges that users might experience when using nesting solutions. And these come largely because in many ways it's a broken and manual process. A lot of the things that you do on a day-to-day basis may be, there's a lot of interaction required to do that, whether that's preparing geometry or converting files, whether it's the lost associative connection between the design data and the nesting geometry. But there's also other things to consider. There's, it's often hard to understand the efficiency of your nests and the cost impact that a nest will have on a project or a product. There's also the additional software requirements to consider. There's the cost of acquiring additional software and maintaining it. There's also the cost of learning that. So there's a downtime associated with learning a new user interface, a new piece of technology. There's also the integration of that into your system to consider. So how is it that you're going to handle these different file formats with any other file formats you're also using? And there's also the change. How do you manage change inside of your business environment, along as CAM solution as well? How can you integrate this as part of a complete process? Now, if we look at that visually, that process might look something like this. We have an engineering department or team that is working on the design of a product. In this case, it's a snowplow. They are doing all the detailed design work, and then we have a production team that are then using the information from the design team or some information they output to then prepare geometry to be manufactured out in the factory or the workshop floor. Now, often that includes an aspect of nesting for laser, waterjet, profile, plasma cutting, or the likes. The challenge is that in many respects, this is often a one-way process. We're often passing information down to that team that is then converting that information into a nest and then sending it out onto the shop floor. The change always comes when there's a change or there's some sort of change process inside of the business, and we realize that we need to modify the design. And that often requires that the nest that has already been created, the investment in designing those nests, is effectively, in many ways, thrown away and restarted from scratch again. Ideally, what the nesting utility helps do is to close that loop, to provide a more seamless integration of nesting into that design and manufacture workflow, so that information in many respects can move between the various different solutions of your design and manufacturing workflow. So in broad terms, the nesting utility is a CAD-embedded sheet metal nesting solution that works directly inside of Inventor. So it's another environment, much like, say, the Nastran environment is, or the CAM environment is inside of that workspace. It comes as an entitlement as part of the product design and manufacturing collection. So that's the way that you can access this technology. And it gives you a wide range of features and functionality to streamline that nesting process. And we'll cover a lot of those things in today's webinar. Now, this is going back to our previous graphic, which showed the traditional broken workflow. This is ideally the type of workflow that we would be looking at trying to implement, one which moves from design, in this instance using Inventor Professional, through to nesting using the nesting utility, and then through to the CAM team or the production environment, then using Autodesk HSM to machine or cut our components using the cutting equipment that we have on our shop floor. And it's through accessing all these technologies, all which are a part of Inventor Professional. So it's embedded technology as part of that workflow that creates a really great design to manufacture workflow, trying to minimize a lot of the disruption we would traditionally see using a more traditional nesting process. And today we'll be highlighting that by working on this snowplow design. We'll be working with the CAD geometry and then moving it directly through to nesting in preparation for, or actually in providing the NC code required to run the design on a local machine. Before we do that, let's have a look at some of the key functionality that the Autodesk nesting utility has. First off, it comes integrated with inside of Inventor. So it's going to work with your Inventor parts and assemblies, much like any other component. And I mentioned before, Nastran or Autodesk HSM, which are both integrated in a similar way with inside of the Inventor environment. So you don't have to use a new tool or learn a new user interface. You're effectively using the same environment that you're comfortable with, but you're simply learning to understand how you can use the nesting module directly within inside that workspace. It comes with a wide range of capabilities. We've mentioned, working with Inventor parts and assemblies. You can also import DWG and DXF files that enable you to work with maybe legacy files or data that you've got from a previous design or previous system, or potentially even files that someone's providing to you. In doing so, it effectively takes a design. In the instance, we'll be working with an assembly. So we'll take that complete assembly and it will filter out all of the components that can be cut, and it will nest them based on material and material thickness. So it will divide those up into multiple sheets of various different materials and material thickness, and it does that automatically for us. It will generate a report as part of this process so we can understand the efficiency, the total number of components that we'll be cutting, the number of sheets required to do that, and give us an indication of cost associated with that process as well. There's associativity between the 3D model and the generated nests, so we can link. We're effectively creating a link between the geometry from Inventor, the design side of things, to the nest, which is then able to be updated. So if we make a change inside of our design, this can be reflected inside of our nests quickly and easily. And we've also got the ability to be able to export this information in a number of ways. We can export it as a DXF file, which could be used with a third-party machine controller to program your local machine, or you can export it as a 3D model. And the value of doing that is it means that you can actually take advantage of HSM, Inventor HSM, which comes as part of the product design and manufacturing collection, to then program your NC equipment to then automate that process even further than what you would just by integrating the nesting utility by itself. So let's have a quick look at the workflow to understand some of those capabilities and what they look like in a little more detail. So like I highlighted, we'll be working with this assembly with inside of Inventor. You can quickly create a nest directly from within inside an existing assembly, where you're given an option to use a number of templates. You can define your own templates and customize those to suit. It's going to automatically recognize the materials thicknesses, and pre-configure that for you, and anything that may have already or might not already be included as part of that template will then be added as required. The process then moves through and looks at all of the source files and defines the geometry that'll be coming from each of those. And you'll notice here that it segregated them down to individual profiles. So even if you've got multiple profiles, it will try and single those out. You will find that anything that's not a profile that can be cut, it won't actually bring in as a profile to be cut. So it's going to look at, in this case, a bit of pipe or tube. It's going to recognize that it's not possible for it to cut that as part of the nesting workflow, and it will remove that automatically from this process. Once we've defined the profiles, we can go through and create a nesting study. We can tell how many jobs we've got to do. We can stack items inside of there. Otherwise, I've accepted the default settings and moving through to running that nesting study. Now, the nesting study in this instance took about 60 to 90 seconds, I think, to generate all of the profiles that you see here. And the report or study includes all of the various different nests for the various different materials and thicknesses that are available. You can see that the report includes information such as the nest name, the efficiency, the number of parts, the total number of sheets, and an indication associated with the cost of this nest. If we look at the sheet itself, we've got a table to highlight the components on the sheet, what they are, and information about the date, the stack size, the total quantities as well. Now, beyond this, we can go in and modify this nest as well. So say, for instance, at this stage, we realized, well, instead of us doing one set, let's do two sets because we needed to have a spare assembly of these components available for the customer. Maybe we want to put in some spares as well, or consumables. We can also adjust the freedom by which the nesting utility has to actually nest the components. So we're giving it the flexibility to be able to mirror these parts, maybe a little bit more freedom in terms of the deviation to orient them to try and get the most efficient placement of them on the sheet. And you'll note that on doing that, it will, because we've got automatic update turned on, it will automatically then rerun that nest and reconfigure the components. Again, it took probably, 30 to 60 seconds to rerun that nest and generate the geometry. And you can turn off the automatic update so that you could move through, make a number of changes inside of various different nests, and then rerun them all at the same time. You'll see that it's now split across two different sheets. Now, in this instance, maybe we don't want it to split across two different sheets. So we can go into what's called the process material library, and I can then define the material size in this instance, based on the material ID of that nest, to maybe change it to a different sheet size. Maybe I've got some remnant stock left over that I want to use in place of this piece that I was using. And I can then go and rerun or recalculate that nest, that individual nest, with this new sheet size to see whether I can get better efficiency out of an existing piece of material or a different piece of material that I have available. So you can see here that I've been able to constrain that all on to one sheet instead of running two sheets. It just meant changing the sheet size. And you'll note here that it's isolated that sheet size out from all of the other sheets, so it hasn't changed any of the other nests that had previously been created. Now, what happens if we wanted to make a change to our design? What happens to the nests? Well, this is one of the key advantages of using the Autodesk nesting utility inside of Inventor, is because we can move back to the design geometry and implement a change. In this case, what I'm going to do is simulate the idea that, well, I've realized at a latter stage after the design had been released to production that we actually missed a couple of holes in one of the components. So let's go and add on one of our plates a couple of holes that are required for whatever reason to our design. We'll update the assembly and save our components to make sure that the changes migrated across to all of the subsequent documents, including the original document we were making the change to. Once we've done that, we'll move across to the nest, and I'm just going to go back to the sources area and hit start extract, and that's going to it's going to kickstart that extraction process again, just to look at any changes that might have taken place. And you can see here that it's highlighted that there's a change to nest 6 that requires updating. And all I simply do in that instance is recalculate the nest. And you can now see that as a result of that, we've now got the updates in place. So it's just gone and recalculated that nest. It's not gone and recalculated any of the other nests. So they're also the same. And in this instance, it's just replicated the change. Now, what happens if we want to move that design out to production? Well, we can export that. We can export here as a DXF that could be used by a third-party package, or we can create a 3D part from this nest. Now, in doing so, then we can leverage the advantage of using the CAM module inside of the product design and manufacturing collection called HSM. And again, this is embedded directly with inside of Inventor, where you can quickly and easily, in this instance, cut this design using a profile cutter that you might have on the shop floor. We simply set up the process for the specific type of cutting process that we want to use. We can adjust a number of parameters around the way that it's going to do that. In this instance, we're going to quickly and easily choose all of the profiles on this sheet here. We can use technology like tabbing. So if we wanted to tab the items onto that sheet to ensure that they didn't drop out as we were cutting them. In this instance, I wasn't so concerned about that. We can generate that toolpath, simulate it to understand what it's going to look like and make sure that we're happy with the toolpath that's being generated. And then once we're happy with that toolpath, then we can move off and then post-process this and send it out to a machine on the shop floor. So you can see here, and you can see on this page that we've got a wide range of post-processes that come as part of the HSM installation. And there's very good support on the forums and the front by the CAM team around post processes and the availability of those. So in essence, you can see there quite a comprehensive workflow from initial concept right through to final production. A nice, neat workflow of moving your detailed designs through a nesting solution to nest your products onto sheets based on thicknesses and materials, even grades. And then even going as far as post-processing that information and sending it out to a local machine. So, to give you a little bit of an understanding of the nesting technology comparison, because the nesting technology that we're talking about today, though new to the Inventor workflow, nesting technology is not new at Autodesk at all. Actually, you've probably heard of a solution called Autodesk TrueNest. And TrueNest is another solution that's available for you. The nesting utility is an integrated solution. It comes integrated with inside of Autodesk Inventor. The TrueNest solution is not an Inventor integrated solution. It is a standalone solution that works outside of Autodesk Inventor. Both solutions come with the ability to be able to import common CAD files. In the nesting utilities situation, it enables you to work with IPT, IAM, DXF, and DWG file formats. Autodesk TrueNest even comes with a broader range of capabilities in being able to bring in typical CAD geometry and formats. It comes with automated TrueShape nesting technology. Actually, some of the technology that the nesting utility comes with is being borrowed from or used from the TrueNest solution. TrueNest also enables you to do things like nest editing and comes with the ability to be able to integrate with a Vault and a PDM solution. Both of these technologies, I believe, are currently under development inside of the Autodesk nesting utility team. Furthermore, if we look at some of the other features and functionality, again, you've both give you the ability to be able to do a DXF export out. Both give the ability to be able to post to laser, water jet, and plasma cutters. In the instance of looking at the nesting utility in isolation, this is done through Autodesk HSM, where you generate the NC code using the posting process there. You can use, again, CNC routers, again, in the instance of the nesting utility. This is done through HSM. But the Autodesk TrueNest does come with the ability to be able to support punch presses, saw cutters, ply cutters, and automated cutting optimization as well. Furthermore, Autodesk TrueNest has some advanced technology that helps you manage your stock inventory or remnant tracking. So if you've got sheets that you've cut, but you've got leftovers, it will help you manage and track that. It enables you to capture multiple machine profiles, do things like scheduling and capacity planning and production management. It can integrate with an existing database or an ERP system. And it's a very automated system, effectively enable you to automate to the point where you can look at a lights out type operation. So moving on to some frequently asked questions. Firstly, who has access to the nesting utility? Well, if you've got the product design and manufacturing collection, then you can get access to the nesting utility. For those of you who have Inventor or Inventor Professional, unfortunately, the nesting utility is only available as part of the product design and manufacturing collection. When will the nesting utility be available? Well, the good thing is that it's available right now. From early April, the utility has been available, though it is a separate download. So if you're expecting that you're going to install Inventor Professional as part of your product design and manufacturing collection entitlement, and it will come pre-configured and pre-installed, it doesn't. It's in many respects, it's like Nastran in CAD or HSM. It requires a separate download and a separate installation to activate that functionality with inside of your Inventor Professional solution. There are a range of languages that are being supported by the product. So whether it's English as your primary language, or maybe Chinese or Japanese or German, there are a number of languages that are being supported across this solution. And, in terms of current limitations, the current limitations is that it must be using the 2019 version of Inventor. So if maybe you're still using Inventor Professional 2018, you want to use the nesting utility, unfortunately, you won't be able to do so until you upgrade to the 2019 release. And when it comes to Vault integration, there are some limitations in terms of the way that you can work with those files. If for further information about additional limitations, then refer to the nesting utility README file. Otherwise, how can you get access to this information? Well, you can get access to it, to the nesting utility in a number of ways. If you've got the Autodesk desktop app installed on your local machine, you should see that you can install it directly from there. So you should be able to open that. If you're not already logged in, you just log in. It will show the entitlements that you have available to you, and you can simply click install, and it should run through the process of installing that solution onto your local machine. Another way of accessing this information is to log into your account, your Autodesk account, and download that, where you can find the installer and any subsequent updates. You will note that using the desktop app will also prompt you if there's a recent update associated with any of the solutions, not only with the nesting utility, but with any other solutions that are available. Furthermore, if you want to get your voice heard, then there is no specific nesting utility forum as such. Most of the interactions are taking place through the Inventor forum. But if you want to provide some feedback, not only in regards to the nesting utility, but other technologies around Inventor, a good place to start is the Inventor beta site, where you can log in and get early access to technologies like the nesting utility prior to them becoming available as a commercial release. So you can give early feedback about the workflows and helping to improve the products as they're being developed. Another area that you can provide feedback is the Inventor Idea Station. So if you've got improvements with maybe the nesting utility, or more generally with Inventor, then a great place to go to provide that feedback is the Idea Station, where you can come up with ideas for new features, new workflows, improvements, additional technologies, and have your peers, people outside of the community, vote on your ideas, and you can likewise vote on theirs. Otherwise, it's quite a brief session today. We've had about a 30-second session on looking at the nesting utility. I am actually hoping to be able to run a more in-depth look at the nesting solution down the track. So keep an eye out for a future webinar where I do a bit more of a deep dive to look at the the features and functionality, is actually quite an extensive technology in terms of the range of flexibility in setting it up and configuring it to suit your needs. So I'm hoping to be able to go into more detail, time permitted, a little bit later on. If in the meantime you've got questions about the nesting utility, then please feel free to reach out to your local reseller. If you don't have a reseller or you're trying to find a reseller, you can go to the autodesk.com/resellers web link and do a search in your local area for one. If you'd like some further information about the nesting utility, you can go to the website, which is autodesk.com/products/nesting-utility. Otherwise, if you've got questions you'd like answered about the webinar today, feel free to reach out to me directly. My contact details on the screen shown, including my email address, and feel free to connect with me on LinkedIn. Otherwise, I know it's a bit of a brief session today. I appreciate your time in coming. It looks like in Melbourne it's turning a little bit nasty outside, which doesn't surprise me. But thank you so much for your time. Really appreciate your attendance today. Keep an eye out for other future webinars that we'll be running over the next few months, and hopefully we see you at those again. Bye for now.